Hi, my name is CHENMENG. My part is problem statement. Over the past decade, global sales of EVs have experienced significant growth. However, predictions of future sales developments, which are needed for the planning of EV production and will and supporting policies and a sufficient energy supply, are still sparse.
My part is about the solution buyer. My part. Electric vehicle manufacturers benefit from effective sales and market expansion. By targeting buyers, they boost sales and establish a strong presence in the growing electric vehicle market. Meanwhile, policymakers' sustainable goals support electric vehicle promotion, aligning with pollution reduction and a sustainable transportation system. For environmentally consumers, electric vehicles' clean image attracts them, supported by government incentives. Technological innovation and the eco-friendly lifestyle association appeal to consumers interested in progress and image.
Hi, my name is ZHONGQI, and I'm gonna talk about the analytics tool used in this paper. The author collected data from secondary sources for 26 countries and developed a logistic growth model to forecast EV sales. They also conducted sensitivity analysis regarding the number of data points. Two software programs, GeoGeBraf and Mathematica, are stated to be used in data analysis and model development. So let's dive into the specific use of these two programs. Firstly, GeoGeBraf is a free digital tool and does a bunch of cool things like class activities, graphing, geometry, and even a collaborative whiteboard. For our paper, they use GeoGeBraf to model EV inventory forecast using a logistic growth function. Check out the formula GeoGeBraf magic right there. Next in line, we have got the Mathematica. It's like the superhero of math software. It got all the tools for hardcore number crunching, data processing, and plotting. In our paper, Mathematica played a hero role, doing calculations to help with the predictive analysis. So, there you have it, GeoGeBraf and Mathematica.
Now let's see the objectives and prediction methods. To begin discussing prediction methods, it's important to first consider the objectives we are trying to achieve. By setting clean goals, we can identify the most appropriate prediction methods to use. Therefore, our objective is to predict the future inventory of electric vehicles across 26 countries, while assessing sustainability impacts. Predictive analytics covers a variety of forecasting methods and techniques. Here we have chosen the predictive modeling method, logistic growth function. This paper uses the logistic growth function to demonstrate the forecasting process using China as an example, and uses this to forecast the total inventory and electric vehicle sales in 26 countries.
Next are the findings of the research, and it will be presented by me, Dimas Suryadiyanto. The 26 nations were divided into 6 categories based on their EV adoption rate and changes in CO2 emissions. This is the stage list for each category. These are the cluster and the list of countries that represent it. In general, there are 3 factors that divide them, which are government policies, charging infrastructure availability, and the type of energy usage. Next is the implication part. The expected EV expansion will increase energy demand in the next years, and this prediction will have implications for energy and battery production. Starting with the need for a significant increase in battery production, rising electricity usage, and raw material availability issues. Despite these challenges, EV business could generate $294 billion in 2030 in 26 nations.
What we can get from this paper, we can get 3 points. First, this paper shows long-term forecasts of EV sales in 26 countries until 2035. Second, the logistic growth model predicts that 30% of all passenger vehicles will be EVs in 2032. Third, significant coordination differences are established regarding sustainability implications. Are our predictions thorough? Answer is yes. Firstly, the logistic growth vacations fits much better because a saturation limit can be expected. Secondly, the study's estimations are mostly corrected downwards and below predictions based on actual EV sales. Regarding the limitations and advice of this paper, we summarize 4 points. First, we suggest that future research should investigate this more deeply based on our growth projections. Second, the more data available, the better the predict model. Third, is the estimation of saturation limits. Fourth, there are some uncertainties that should be considered in future studies.